Now we will be moving to the next topic, that is file handling with Python. But before moving ahead, have you ever observed one thing? And that thing is, up to now, we have written a lot of programs, but all of those programs actually had a problem. So to understand that problem, suppose that we created a student management system and you entered a list of 100 students. Now everything was working perfectly, but only for the time when the terminal application is actually running. The moment we actually close the application, all the data that we entered eventually disappears. And why this happens? Because variables can store the data only while the program is running. And once the program ends, all the data is lost permanently. So how do we actually solve the problem? And you might be thinking that how do Notepad, how do these word processors like MS Word, Vim, and others save the progress? And how do the games, the video games that we play, store our progress? And we actually resume from the particular point that we have left in a particular game. So how do all this happen? So the simple answer is file handling. And file helps us to store data permanently on our computer systems. And today we will be beginning with file handling. And but what is a file? So a file is simply a collection of data stored permanently on your computer. That is your secondary memory. That is your hard disk. And whenever we want the data, we just simply tell the system by a program code, and the system just fetches the file into the RAM. It loads it, and we are able to just see that the output or the data that is contained inside that file. So examples of files are .txt files, and you can see .py files, and JS1, that is JavaScript object notation files, JSON files. Then we have various audio files, MP4 format for video files, and there are others like image file and drawing file for drawings, and CAD files for AutoCAD. There are a lot of extensions and different types of files. So I hope we have a very good introduction to file handling, and to actually use and modify a file and to illustrate you how to work with files. I have already created a sample.txt file in the main folder of the lecture where I am actually currently teaching you. And let us now begin with how we can actually access that material or the data that is stored inside that file. So to do that, you simply can create a variable, that is, I can create a variable data, and I can say open, and then I will provide the file path inside these strings. And if the file is actually in the parent folder, that is the folder in which this Python file is already existing, then you can give a relative path. That is, you don't actually need to mention all of the characters that appear in your path. And if the file is there somewhere else other than this directory, that is the parent directory for this file, then you will have to give the absolute path. And I hope you would surely be knowing the absolute path and relative path. And if you don't, then you can actually go to Google and ask for much detailed explanation, and you will get it. So the file's name is sample.txt, and I want to open sample. So what will happen now? All the data that is inside this file is actually stored inside this data variable. And by default, we actually have not mentioned anything about what we want to do with this file. That is, we have just opened the file. We did not mention that if we want to actually read the content of this file, or we want to write the content, or we actually want to add some content, that is append some content in this file. So in this case, Python will automatically assume that we want to actually just read the sample text document, and it only gives us the permission to read the file. So how to read the data inside this file? So the simple way is, so now we can create a new variable to print the data inside this sample text, and let me just name it sample text, and I will assign the value data dot read. This open function simply means that I will fetch the data from this sample.txt and then give the data to this data variable. Let me just name it to storage so that you don't get confused with the data variable and the data stored inside this file. So what will happen now? When this open function will run, it will simply fetch the data and then place it inside this storage variable, and we have now created another variable, that is sample.txt, and we have now used the read function, which will read the entire file, the entire data that is inside the sample.txt. And when you're going to print this sample text, we can actually see what is the data inside the storage. Now you might be wondering that why do we actually need to do this much of task if we can simply do by this way, that is storage dot read, and the answer is yes, gets cut off in my region, and the system just shut down immediately. So what will happen to the file as the file is actually still open? What will happen in that case? The answer is file may get corrupt and the data inside this file may get damaged or completely lost. So to avoid that, we always use a close statement. That is, we will now use storage dot close so that the file actually gets closed after we successfully read the data and print it on the terminal. And you can say that it just flushes and close the input output object, and if the file is already closed, then this method will not give any effect in the terminal, or you won't see any output. So when I run this file, mm, let me just check for the name. The name is actually correct, sample.txt, SMPL. So when I want to run this program file, we can see that there is an error, and the error says that file not found. That is, it says no such file or directory sample.txt. But why this terminal shows this kind of error when we already have a sample.txt in the folder? So the reason is we actually opened this folder. Yes, you observed it correctly. This read method even prints the empty lines if there are empty lines in the sample.txt file. But will it print all of the empty lines if there are many? So let me not answer it, and you can see it in the terminal. So the answer is yes. It will print each and every empty line that is there written on the sample.txt. But what if we don't want all these empty lines to be there on the terminal? So there is a function, and not a function but a method, and it is a string method. You can actually use the strip method to remove the white spaces from right and left ends of a string, that is from the starting and the ending of a string. And if I'm going to run this same piece of code now, you will see that there is no white space. Let me just read in the program, and you will see that there is no white space, but there is white space in the file. So this is how we use the strip method. Now that we know that we need to open a file to read it, then we need to store the file, then we need to read that stored variable using the read method, and we can simply print that read content on the terminal, and this is how we can access the content inside a file in read mode. And after we read the content, we actually have to close the file. But this is only the read function, and this is actually not even a very good approach to solve the problem of reading the files, because suppose I'm writing a very large program and accidentally I forgot to close the file. So in that case, my program would either give me an error if it did not end successfully, or the data can be overwritten each time, and there can be other errors too. So how to solve this? So we actually have solved the problem, but before we move to the solution, let me just show you how we can actually open this file in write mode. Now, to do this, you just need to go to the open function, and after you type the file name of the file, you just put a comma and specify the mode. That is, you can actually see there are a lot of modes, but I don't want you to actually get confused and frightened when you see these modes. And the reason is we will rarely use all of these modes in the programming journey. We just need the three modes, and those are read mode denoted by this, and this is the by default mode. That is, if we don't specify anything over here, then Python automatically assumes that the file is open in the read mode. And the second is the write mode, that is denoted by W, and the last is append mode, that is denoted by A. Now, to actually overwrite the contents of a file, that is, if we choose to write the file and we simply started to write in it by this way, actually we don't need to create a variable this time. We can simply and directly write to the file. Suppose I want to write this is this text is written during the lecture, and when I'm going to run this file and I'm going to check sample.txt, you can see that the text which was initially hi, you are inside sample.txt is actually now changed, and the old text has now been replaced by this new text which says this text is written during the lecture. So I think you would surely have observed that this write mode actually deletes all the pre-contained data in a file and start. Now that we have seen how append can be used to create files and write text to them, and let us now check how we actually can append text to the file that we created, that is this file .txt. And when I want to run this piece of code again, you will see that this text appeared in the second line, and when I want to run this text again, you will see that it actually continued in the same line. Why this happened? So this happened because by default, if we actually press enter, that cursor comes to the next line. And when we are going to run this file, you will see this time that the text is there in the next line. And if I place the cursor in the second line and run the code again, you will see that this again continues. So how is this working? Escape sequence character in a string. Now let me just actually delete all the text inside this file, and let me delete the lines too. Now when I'm going to write in this way, you will see that in the very first line, this line appears, then a new line is actually created, and that new line, this text will appear. So let me just clear the terminal, rerun the Python file, and you will see that the code works successfully. And now that we have seen all of these modes, let us now take a look back at the problem that we actually discussed earlier, that is closing this file every time. So you know that it is quite a very risky process to open and close a file in a different piece of code, that is in a different line of code, because if you accidentally forgot to close the file, then the data inside that file is actually at a very big risk. So to solve this problem, we actually have the syntax, and we actually use this syntax, that is with open, then we give the file name, that is file.txt. I will simply use the R argument, and now if I'm going to create a new variable, that is data, and try to put all the content from the file too after reading into this data variable, and now if I try to print the data, you will see that the data in the this variable data is actually printed. So in this case, we actually don't need to close the file manually each and every time, because we have used a keyword with. Now this with keyword automatically tells the Python interpreter to open this file, then read the file or execute what is there inside this block of code, and after that just close the file. Our task is actually now done. And in this way, this with statement works, and this is a much safer approach when compared to the previous way that we followed in this lecture. That is, every time we had to open a file, then we had to make changes, and then we just close the file. So this is a much better approach. Now, all of those methods that you actually implemented on that previous approach can actually be implemented over here, and you can even read the data line by line. And if you want to dive more deep into the concept, you are free to go and read the documentation, the official Python documentation, or go to any of the. By this point of time, we have actually covered all we had to cover in file handling. So to satisfy myself, let me just give you some more attributes or the values that you can actually give over here to open the file in different modes. So the first mode is R plus. When you are when you will use this R plus mode, you can read and write the file at the same time. And there is a W plus. I don't want you to actually get scared of. You will actually discover them as you continue in your journey. And despite these six modes, that is these three modes and the three RWA mode, you would rarely have exceptions and exception. So let me just name it lecture number 9. and I will create a new file that is exception.py, and we will now begin with exceptional handling in Python. So I hope by this point of time you would surely have seen a lot of errors in your program and even in the video lecture series too, because we have actually discussed a lot of errors and we have already discussed how and when those errors occur and how to solve them. So I can now expect that you are at least familiar with the word error and some of the very basic technicalities that why the errors actually happen. I don't want and I don't even expect from you guys at this level to actually know the very deepest root cause of what is actually happening internally, but I just want you to know the overview that what happens when something goes wrong. So if you actually know that that's something, that's some overview, then you are very good to go with this lecture. And inside this lecture, we will actually be learning how we can handle those errors. That is, suppose we don't want to throw an error to the user because the user might get trace back most recent call, the last and whole but we actually don't want the user to have a look at what are the internals of the program. That is, it shows the file name, but we don't want the user to show the file name. We don't want the user to see that in which line this piece of code is actually written, because the user who is using the program can actually be a person who can hack your files or who can misuse your files, and even in worst cases he can leak the private or the very sensitive data from your files over the internet by using or by just knowing that where the location of this file is and some minor details that like where the specific line of code is written in the program, that is in the second row. And to avoid this, we actually give a user or the programmer's defined error to the user. That is, we define our errors, or we actually tell the Python what to print when a particular error occurs, and it will simply print that instead of giving this entire string in the terminal. So how to do this? So we to do this we have try, then we have except block in Python. So how do this try except block work? So assume that some code is actually written in the try block. What will happen? Python will simply try to execute that code as this try keyword suggests, and if the output or the program r- was executed successfully, then there would be no error. And in that case, this except block will not whether the program has actually been terminated unfortunately or whether the program was successfully executed. In each and every case, this finally block of code would be executed, no matter whether the program crashes or anything. Now that we have seen the finally statement, we will see we will explore this block of code, that is try except else block of code, later in the same section or in the same lecture. But for now, I am just skipping it. Ask the user for an input of two numbers and then divide the first input by, okay, for the sake of programming, we will actually be using float instead of int. So we'll hide the try block and inside this try block we will enter num1 and is equal to input, and then simply enter the first number. Then we will create num2 and input from the user, take input from the user and say enter the second number, and we will be actually typecasting them into integers or float. Say we will be typecasting both of them to float, and now we will be storing the answer of the division into the div variable, or let us better create a answer variable and store number 1 divided by number 2, and then we will finally print the answer. So this is the basic code that we actually want to execute, and let us now write the execute part, accept part, I'm sorry. Now I want to accept each and every error. So writing a accept statement like this is something like creating a generalized exception for each and every exception. That is, it doesn't matter what kind of exception is going, but instead it is forcing the Python interpreter to actually return this print statement instead of that predefined error. So this is the application of exception or the except block in Python. If you did not see the output earlier, you will be able to compare it now. When I run this piece of code, you can see that print 1 by 0 statement returns a zero division error. But when I'm going to do so, when I want to do the same using the try except block, you can see that now it returns something unusual happened, and this is the visual proof that you can see. Now, what if I actually want to tell the user specifically that you have actually done something that is not accepted, or I should say not defined in mathematics. So in that case, I will simply be returning on zero division error only that division by zero is not possible. And when I'm going to run this piece of code and I deliberately enter 0 as the second number, you will see that it says zero division error is not possible. But what if I try to enter a string as the second number? You will see that it gives me this value error, that is, this cannot be converted to a float. But was this case there with the previous part of code, that is an except statement without any kind of error mentioned? So the answer is no. So when I'm going to enter the number 90 and the number 9 and try to divide them, it says this was successful. But what if I actually tried to enter the first number as 90 and second number as 0? It says something happened, but it did not execute the else part. So by now you would have understood that this else block is actually going to be executed only when the try piece of, that is the code inside the try block was successfully executed. And if there was any kind of error, in that case this except block would be executed and this else block would not be executed. Now let us see the case of finally true. So finally I want to print the program has ended. Now, if you want to run this piece of code, you will see the output. Now, let us enter the first number to be 19, second number to be 9 again. And when I'm going to run the code by pressing enter, you will see that it says 10.0 and the program has ended. Why we are actually seeing this program has ended when the try statement is actually executed successfully? So to understand this, let us actually execute the code once again in the terminal, and let us see what happens if we try to enter something invalid. That is, I actually entered O in this as the second number, and it should now give me an error, and this except block should actually be executed. What? You can see that it says the program has ended. So did you get something from this? It is obvious now that this finally statement would actually be executed in every case, even if your program executes successfully, and if it does not do so successfully. So using these try, except else, and finally blocks, you can create a, a program that throws the error that you actually want it to throw. And this was all in this try, accept, else, and finally part. It don't intimidates you when you see it the very first time somewhere written on a website or in somebody else's code. So let's cover that part too. And to continue with that part, let me just paste the code snippet directly. And mm, let me just, yeah. So now you can see this code snippet on my screen and your screen too. And you can see a raise keyword inside. You know when value error actually do occur? It occurs when we try to enter a different data type inside a predefined input. That is, the input should actually be integer. But if we try to enter a string, it says value error, that invalid literal for int with base 10. And this error actually says that you are trying to give input as a string, but we are accepting an integer. And this is the by default value error of Python of the Python interpreter. But we are actually giving dive into this part, and I want you to actually. So now that I have shown you the raise keyword, I hope that you won't be scared when you see others written code, and you would that we use to handle errors and exceptions in our program. So in this lecture series, this is all that I would want a beginner to get his hands dirty with writing a lot of code in Python. So I hope you would have actually enjoyed the series, and if not enjoyed, you would actually have taken at least some very. And this was all from my side in the exception part. Now that I have showed you how we can actually use the raise keyword, I am quite confident that you won't be hindered when you see something like this. And we have covered almost everything. So what is a module, library, and what is a package? What is the main difference between them? So all of them actually have some difference, but let us begin by the difference between a module files of pre-written code that is written by some other user, and we want to actually download them over internet or by some other means, and then directly implement or directly use the methods defined inside that code into our system without redefining them. And this is done using. And before I tell you how to install with the help of pip, let us discuss what are the different types of modules. So there are actually two types of modules, and those are built-in built-in modules and external modules file in your Windows system, and these can actually be directly accessed without downloading because they're already present on your system. But the case is not same with the external modules. In case of external modules, you actually have to go and download. So you can think of pip like a personal manager for Python. It manages everything. So you might be wondering if there is a full form for pip. So the answer is the full form of pip is Python install packages. So this three terms, that is Python install package, is shortened to pip. This is the full form of pip. And how do we use it? We can directly use it by the terminal. That is, we need to go to the terminal and simply we have to write pip. Then we will tell pip to install. So instead of going with some hit and trial method, you should actually always refer to Google. And the reason is because you can accidentally download some other library or some other package that is having similar name to Flask but has some different function. So you should always look for the exact name. So to look for exact name, we will simply be going to the Google Chrome web browser and search how to install Flask on VS Code. Now you can see that the command is pip install Flask luckily, and let me just write down the command, and when I want to hit enter, you can see that this package is being installed and it was finally successfully installed on my system. So this is how we actually install packages. Now, one more thing that I want to tell you is there might be many versions of the same package and those packages, but for your knowledge, I considered this part important to be discussed with you. So now we will be taking a look at how we can actually import and use the module code that is pre-written in that particular module and use that code. So to do this, I will simply be using the code snippet that we got from the Google Gemini to check if the code actually works. So this is a pre-written. So I have shown you a sample of how you can actually use this import statement to actually import a particular function, or I should say particular part from the Flask module, and then use that particular part to write a piece of code and execute. And you can see that there is some output. So now we have seen that how we can actually import a module and write code and then make something useful from that module. Now let me just tell you something important. What if we actually had to build something but we don't know what to do and where to go? What would you do in that case? So, and then simply ask for any AI or to the Google itself that how can I create a weather app with Python, and it will tell you all the necessary details that you actually want. So you can actually read this prompt by giving this prompt in your system, and it will tell you all the details. Like in my case, it is telling me to install me a module that is a request, and it is nothing but the HTTP. So this was the answer to this question, that what if we do, and if in some cases this type of prompt is not helpful for you, then you can search like this: modules that can help create a weather app in Python. So it will simply give you all the module links. That is, it says for data fetching and API communication, you can use this modules. Then for a GUI app, you can use these modules. And for web and dashboard frameworks, you can use these modules. And you can go either in this way or in that previous approach that I just showed you, that is this one. Both of them work fine for me, but you can choose which works better for you and use that approach. So now I have actually showed you how you can actually work with modules and how you can make your own projects. I think you should practical part in this series where I will be actually making and I will be illustrating you with the approaches and the methods. I hope you would like this. And if there is anything that you want me to improve, that you want me to go in more details, just hit it in the comment section and I will surely pin your comment and try to answer your doubts too. And if you think that this content is not enough, then just simply write in the comment section, not enough. And also, and one more thing I don't want you to ignore is that if there is a conceptual error or there is something that I explained in the wrong way and you did not understand it, or the concept that I taught are actually incorrect and are obsolete from Python, then in that case you can surely, and I think you